In the previous class, we have done the overall significance of the logistic regression model. In this class, we will go for testing the individual significance of all independent variable. So, the agenda for this class is testing the significance of logistic regression coefficient, then we will do the Python demo on logistic regression. In the previous class, I have stopped by saying the G statistics and corresponding p value, that p value was less than 0.05, then we have seen the overall model is significant. So, this is the code from Python to get the for different chi-square G value and degrees of freedom. So, chi-square dot PDF 13.628 was our G value in the previous lecture, 2 was our degrees of freedom because there was 2 independent variable. So, this was the p value. So, the p value is very low, we can say that the model is significant. Z test or Wald test. Z test can be used to determine whether each of the individual independent variable is making significant contribution to the overall model or not. For example, how we got the Z value, if you divide 1.0987 divided by 0.447, you will get this Z value. Similarly, when you divide 0.3416 by 0.1287, you will get this Z value. So, corresponding probability, you see this one, both the probabilities are less than 0.05. So, we can say both the independent variable is significant. As a whole model also significant, the independent variable in a logistic regression model also significant. Once we came to know both are significant, then we will go for interpretation of its output. So, what kind of different strategies that company has to adopt so that they can improve their revenue by selling more coupons. Suppose Siemens wants to send the promotional catalog only to customers who have a 0.40 or higher probability of using the coupon. So, what will happen? You look at where it is a 0.4, here this one 0.4. Those who are having credit card, those who are not having credit card, the 0.4 is here. So, what interpretation from this table is, whoever having the credit card and whose spending is $2000 and above, for them you can send the coupon, they will use the coupon. Those who are not having the coupon, but their spending is above $6000, for them you can send the coupon so that they will use that one. So, this is the managerial interpretation. So, customers who have a Siemens credit card, send the catalog to every customers who spent $2000 or more last year, because the 0.4 is the cutoff. Customers who do not have the Siemens credit card, send the catalog to every customer who spent $6000 or more for last year. So, that is the strategy for the promotion. Now, we will go for interpreting the logistic regression equation. For that, there is a close connection between odd. What is odd is probability of success divided by probability of not getting success. So, generally the odd is p divided by 1 minus p, that is odd. So, probability of y equal to 1 is the success, probability of y equal to 0 is not success. So, probability of y equal to 1, given that a different independent variable, that is a numerator p. So, 1 minus p of y equal to 1, that is 1 minus p, this function is called odds function. Then from odds function we are going to the next term, odds ratio, because this odds ratio is very helpful to explain the coefficient of logistic regression equation. So, the odds ratio is odds 1 divided by odds 0. That means when 0th level what is the odd, when the first level what is the odd. So, 0th level means, for example, those who are not having credit card, that is odds is 0. Those who are having the credit card, suppose we are jumping from one level to another level, odds 1 is those who are having the credit card. So, the odd ratio measures the impact of odds of 1 unit increase in only one of the independent variable. So, this odds ratio will help us to interpret the logistic regression equation if the independent variable is increased by 1 unit, what is the effect of that on the dependent variable? We will interpret this. What is interpretation? For example, suppose we want to compare the odds of using the coupon for customers who spend $2,000 annually and have a cement credit card. So, that is this category. This X1 is a 2000 having the credit card, to the odds of the coupon for customers who spend $2,000 annually and do not have the cement credit card. So, what will happen here? X2 will become 0. So, X1 equal to 2, X2 equal to 0. So, that is the second category is the odds 0, the first one is odds 1. So, the ratio of that 2 is called odd ratio. So, we are interested in interpreting the effect of 1 unit increase on the independent variable X2. So, 1 unit increase means here person having not credit card to a person having the credit card. So, the 0 level to 1 level. The 0 level is no credit card, the 1 level is credit card. Okay. So, what is the impact of this one on the estimated value of y? Yeah. First we will see odds 1. Odds 1 is a person having the credit card. So, P of y equal to 1, X1 equal to 2, spending is $2,000, X2 equal to 1, having the credit card, this is the numerator. Probability of success, we can say probability of not success, 1 minus P of y equal to 1, X1 equal to 2, X2 equal to 1. So, what will happen? You can substitute this when X1 equal to 2, this value, and having the credit card, that is this 0.0499. So, when you substitute this 0.4099 divided by 1 minus 0.4, we are getting 0.6946. We will go to the odds 0, 0th level. So, P of y equal to 1, X1 equal to 2, X2 equal to 0. This case similar to previous one, spending amount is same, but is not having credit card. For that the probability is numerator is P, denominator is 1 minus P. So, what is that category? This one 0.1880. So, 0.1880 divided by 1 minus 0.1880, that is giving 0.2315. So, when you divide this 0.6946 divided by 0.2315, this 3. So, the 3 is very useful for interpreting. What is the meaning of 3 is the estimated odds in favor of using the coupon for customers who spent $2,000 last year and have a Simon credit card are 3 times greater than the estimated odds in favor of using the coupon for customers who spent $2,000 last year and do not have the Simon credit card. So, that means expenditure is the spending amount is same, but when you send this coupon to the person who is having the credit card, there is a 3 times more chance that person will use that coupon. Okay. That is the meaning of this odds ratio. The odds ratio for each independent variable is computed while holding all other independent variables constant. For example, in the previous case also, where the expenditure, the amount spent, that is expenditure is taken as the constant, we have interpret only for a person having the credit card or not having the credit card. It does not matter constant values are used for other independent variables. So, we need not bother about the constant variables. For instance, if we computed the odds ratio for Siemens credit card variable X2, instead of 2000 you say $3,000 expenditure instead of 2000, as the value of the annual spending variable is X1, we would still obtain the same value of estimated odds ratio. So, the constant does not matter. Thus, we can conclude that the estimated odds of using coupon for customers who have a Siemens credit card are 3 times greater, that is important interpretation, 3 times greater than the estimated odds of using the coupon for customers who do not have the Siemens credit card. So, you have to target to a person who has the credit card. When you target to them, there is a 3 times more chance that people will use when compared to those who are not having credit card, they will use the coupon. Now another very useful relationship, instead of finding odd ratio that way, there is a connection between the coefficient of logistic regression equation and the odds ratio, that is this one, e to the power beta I. What does the title says? Relationship between odds ratio and the coefficient of independent variable. The beta I is called the coefficient of independent variable. So if you want to know the estimated odds ratio for x1 variable, that is the amount spent, e to the power b1, in our equations b1 is 0.34, where we got this one b1, I am going back this one. So here we are taking x1 variable, this is x2 variable. So e to the power 0.3416, that will give you the odd ratio for this variable, because in some software packages, for example Minitab, they directly give the odd ratio for each independent variable. But in Python we can calculate the odd ratio using that relationship e to the power beta 1. For example, if you want to know odd ratio for card, those who are having card or not, so e to the power 1.0987, that will become 3. I will show you that one. Yeah, see that b2, e to the power b2, the e to the power 1.09873 is 3. So odd ratio we can directly get from the coefficient of logistic regression equation. Now so far we have seen there is 1 unit change, then we have seen what is the corresponding effect on the dependent variable. Sometime what will happen, what is the meaning of 1 unit change means, suppose we have taken for x2 equal to 0 and 1, we have seen 1 unit change. If there is 1 unit change, we have seen effect of that on the dependent variable. For example, this is a discrete variable. If the independent variable is a continuous variable, for example, see x1 is amount spent. Suppose somebody is spending $2000, what is the probability that people will use the coupon? So we can see 2000 to 3000, that is x1 equal to 2 to 3. If it instead of 1 unit jump, we can go for 6 unit or 5 unit jump at a time, and corresponding interpretation we can find out. That is the meaning of that change of more than 1 unit in the odd ratio. The odd ratio for an independent variable represents the change in odds of 1 unit change in the independent variable, holding all other independent variables are constant. Suppose we want to consider the effect of a change of more than 1 unit, for example C unit. Instead of 2 to 3, I want to say 2 to 5. For instance, suppose the Simmons example that we want to compare the odds of using the coupon for customers who spend $5,000 annually to the odds of using the coupon for customers who spend 2,000. The increment is not 1 because it is a 3. Okay. In this case, C equal to 5 minus 2 is 3, and the corresponding estimated odd ratio is very useful. So e to the power c, the c is how much is we are increasing. So when you multiply by 3 of this one, we are getting the odd ratio is 2.79. This result indicates that the estimated odds of using the coupons for the customers who spend $5,000 annually is 2.79 times greater than the estimated odds of using the coupon for customers who spend only $2,000 annually. You see that here the increment is not the unit increment, it is the 3 times increment. In other words, the estimated odd ratio for increase of 3000 in annual spending, yeah, it is a 3 unit means 3000 is 2.79. Then we will come to some theory portions of this logistic regression equation. First we will see what is a logit transformation. An interesting relationship can be observed between odds in favor of y equal to 1 and the exponent of E in the logistic regression equation. So when you say, as I told you previously, probability of success, probability of not success, when you take log of that, that is nothing but a logit function. So log of odds equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta p xp. This equation shows that the natural logarithm of the odds in favor of y equal to 1 is a linear function of independent variable. So, why we are taking log? So that it will become a linear function. This linear function is called logit. Generally in the custom is g of x1, x2 up to xp to denote the logit function. So, when you take logit function, it will become linear. So, interpretation is easy. So, how to estimate the logistic regression equation? We know this is a logit function. If you want to know the expected value of this logistic function, is nothing but e to the power g of x1 x2 up to xp divided by 1 plus e of g of x1 x2 up to xp. So, you can expand this with the help of sample data b0, b1, b2 up to bp. So, this is the your sample value. With the help of the sample data, we can predict the population parameter. Sample, we generally the name parameter is used only for the population, not for the sample. So, e to the power, when I write the hat symbol, it is the estimated value y hat, g hat, g hat. So, you can, this can be written as, because this is right, this can be is nothing but this value. So, we can do logit function. So, e to the power g hat x1 x2 up to xp divided by 1 plus e to the power g hat this one. Why we are taking e to the power and taking log? To make it linear. In our problem so far which I have discussed, so this was our logit equation is minus 2.14 0.34164 x1 plus 1.09873 x2. And if you want to predict y, so here y is the probability value e to the power minus 2141, this we got this answer. Very important things, we will compare what is the purpose of G statistics and Z statistic. As I told you, because of the unique relationship between estimated coefficient in the model and the corresponding odds ratio, the overall test, this is very important, the overall test for the significance based upon G statistics also is test of a overall significance for the odd ratio. But the Z test or the Wald test for the individual significance of model parameters also provide a statistical test of significance for the corresponding odd ratio. This is similar to G is similar to F test, Z is similar to T test. In the this is for the right side one is for linear regression, the left side one is for logistic regression. Now we will go for Python, the data which I have explained you, which I have brought you in the screenshot. I will run that model, then I will show you how to do the logistic regression using Python. Now we will go to Python environment, then I will teach you how to do the logistic regression. So what are the libraries required? You need pandas, you need a numpy, you need a matplotlib.pyplot, you need a sklearn for doing a linear model. You can import statsmodel.api, then sklearn metrics import mean squared error. The file name is simmons.xls. As I told you, this was taken from Anderson, Sweeney and Williams book. So this was the data. So what is happening? I am scrolling, there is 100 data set is there. So what are the variables there? Customer number is there, 1, 2, 3 up to 100. Spending, how much they spent last time. Then whether the possession of the card or not. If the 1 means they are having the card, 0 means not having the card. Then coupon, whether they have used the coupon, 0 means not used the coupon, 1 means used the coupon. First we will do the scatter plot between spending and coupon. When you look at this data, spending is a continuous variable, coupon is the categorical variable, coupon is our dependent variable. So when you run this, you see that you are getting this way. So for this kind of model, whether there is a 2 possibility, it is 1 or 0, in between there is no possibility. So, the linear regression model is not valid here, we should go for logistic regression model. That is one point. The another point is, here the assumption is a linear regression model, the error term will follow normal distribution, but in the logistic regression model error term will follow binomial distribution. So, you cannot go for linear regression model. In X I am taken card and spending, the Y is a dependent variable is coupon. So, x1 equal to sm dot add underscore constant x, logit model sm dot logit y comma x1, result logit underscore model fit. So, I am going to summary of the logistic regression. So, the summary of logistic regression is, see the constant value we need not bother about this, for card it is 1.0987, for spending it is 0.3416. So, after getting this output, what you have to see, you have to check the overall significance with the help of G statistics, that it is not here, but you have to find out how 2 multiplied by minus 60.487 minus of minus 67.301. So, that value is your G value. For that G value, you have to find out by having 2 degrees of freedom, that G value is nothing but your chi-square value. You have to find out what is the corresponding P value. If the P value is less than 0.05, we can say the overall model is significant. The next aspect is checking whether each independent variable is significant or not. That is done with the help of Wald test. So, you can look at here, it is the P value is 0.01 less than 0.05. For second variable also the P value is less than 0.05, then we can say both the variable is significant. Suppose if you want to interpret this model with the help of odd ratio, what you have to do, when you take e to the power this beta 1, that is e to the power 1.0987, you will get a corresponding odd ratio that is used to explain 1 unit increase. Suppose the card person is not having card to having the card. So, what was the corresponding effect on the dependent variable, that can be found out. The spending is a continuous variable. Here also we can find out e to the power minus 0.3416 will give you the odd ratio. So, that will help you to interpret, suppose a person is spending 2000, another person is spending 3000. Suppose there is 1 unit jump, what is the corresponding chances because of that 1 unit jump that the person will use the coupon. Suppose if there is a C unit jump, simply you have to see, you have to find out e to the power C of, that is a C of 0.3416. So, you will get a C unit odd ratio that you can directly interpret it. This is the code to check the G value. For example, as I told you previously, the G value is 13.628, it is mentioned in my PPT also. So, chi-square value is 13.628 and the degrees of freedom is 2. Why it is 2? Because there are 2 independent variables, the corresponding P value is 0.0054, that is less than 0.05, overall model is significant. In this class, I have explained how to test the significance of each independent variable in a logistic regression equation. That I have done with the help of Z statistics, otherwise Wald statistics. Then I have explained what is the odds, then I have explained what is the odds ratio. Then I explained how to use this odds ratio to interpret the coefficient of logistic regression equation. At the end, I have used Python and I have shown how to use Python for running logistic regression equation. Thank you very much.